All right, so we actually prepared a longer form presentation and then adapted to this form after we realized we had a slight error. So we have many slides, which we think we'll use during Q&A. If there are any questions, we can hop around. So there's lots more information where this came from. But we wanted to present to you a project that Joe and I have been working on together in capstone design course here at the University of Illinois, Urbana-Champaign. And the title of our talk today is Experiential Learning, Exploring Nuances when Making Ethical Decisions. And so we teach ethics in our capstone design course here at the University of Illinois. The course is unique because it combines both undergraduate senior design and our MEng capstone experience. So there are undergraduates and master's level students working together in this course. And so they're getting to have this experience together. So that's one nuance that I just wanted to let everyone know about the format of our course. And so what we kind of believe when we set out to design the ethics portion of the design course is that there are many examples of clear-cut ethical decisions that students are often trained on and can be easy to understand that, of course, I want to be a good person. Of course, I want to do the right thing. What we wanted to do is to expose students to the more nuanced situations that may come up when the ethical decision is not clear cut. And we also see that as technology and society advance together, there are changes and new challenges that engineers are facing related to how society and technology inform each other. And so we wanted to expose students further to additional case studies and ideas about ethics and how its interplay with bias in engineering design. So you can see here the Ford Pinto case. So these are this is a classic ethics case study that gets explored in many engineering classrooms, where engineers there was a cost benefit analysis essentially to a redesign of the Ford Pinto based on the location of the gas tank. And so we present these case studies to the students. But what we really wanted to do in our novel initiative is to bring ethical considerations into the engineering design process in a very early stage, and kind of reframe the discussion from the idea of doing no harm to doing the most good. And so we think that this can be done by exploring examples of bias in engineering design. So in our class, we have a kind of a lecture portion and then an active learning activity portion. So I'll talk about some of the examples that we talk about in lecture, and then Joe will take it over and talk about how we get the students to kind of actually dive in and start exploring some of these things for themselves. So I have a number of slides that I'm happy to share on the different cases that we explore in the class. But there are a lot of great texts and research papers that have come out exploring bias in design. So I'll just give you a few of the examples. So there's a great book called Invisible Women that explores the many ways in which women have been excluded from engineering design and in the medical field. The way that crash test dummies are modeled after the average male body, how the symptoms for a heart attack are different for men and women, and how they're taught in medical school. So these are just some examples that are presented in the book, and we bring these to the students to show that based on sex and gender, there's discrimination that happens in engineering. We also talk a lot about how many journals now are requiring that researchers indicate the sex or gender of their participants that they are presenting data on in papers. We also talk about how optical biometric devices such as the pulse oximeter have been published for a number of years, but there's racial bias encoded into these devices because of the optical measurement. The readings are different for individuals with dark and light skin. This was first brought up in the early 2000s, but the kind of attention on this has been reinvigorated due to COVID-19, when pulse oximeters were all of a sudden being used quite frequently again, and the use of many optical-based biometric devices that we wear all the time, like smartwatches. And these devices are more commercially available. And so we talked to the students about how, you know, the individual who's doing the design may have implicit bias based on their own experience, and who devices are being tested on is important to understanding the population that your device serves. There's also a book, Design Justice, and the Algorithmic Justice League is an organization started by Joy Buolamwini, who was at MIT, a student at the time, and she discovered that many facial recognition softwares were trained on largely pale male training data sets, which means that they encode racial bias. And I think it's a really great example. We love to show it to the students because she was a master's student at the time that she discovered this. She published a paper and actually contacted the companies who were using the software and who had created the software, and actually enacted change. She went back and audited them a year or 2 years later and saw that they had improvements in their AI software. So we use it as an example to kind of empower students to think about, you know, speaking up when they see these differences. And so that's kind of the lecture portion of the course. We talk about a lot of these different cases, expose students to design and many different identities that end users have, and get them to think about that when they're entering their engineering design process. And so, Joe, I'll let you take it over and talk about, you know, what's the next step that we do in the course.
Cool. Thank you, Holly. One of the things that we really focus on in the course is really introducing the idea that oftentimes as engineers or people in this kind of STEM space, we're trained to focus on the average, but perhaps in the cases that were just discussed by Holly, where it was looking at cases where they was looking at who was in the majority, who was the test cases for when they were building those solutions. And so we wanted to bring that to highlight that ideal of outliers, and why it might be critical to and ethical to really focus on who might be within those outlier categories, and how I mean focus on those, and at least bring those individuals and those situations into the conversation. So we'll introduce this through a case-based approach. So the teams are already in their design teams or at the early stage of or get into their design teams. And so we provide these case-based studies, and we use a lot of material from the Markler Center for Applied Ethics at Santa Clara that's built. Recently has some cases that was specifically around bioengineering. And some of the cases that we have specifically, we have a slide in if we want to discuss it later, discusses a clinical trial situation where there was a focus on the averages. And so when the experimenter had work done it and identified that for the drug dosage in this clinical trial and how quickly it absorbed into the person's body. And then there was found lots of variation across that. And then the client said, we just want you to give us the average. But by knowing those other components of that experiment, what is the ethical decision? So it might not just be clear cut that do we do exactly what the client says, we stay within a particular test protocol, or the fact that we've discovered these kind of outliers, should that become a main focus? And then within that work environment, how should we, or within practice, how should we handle that? And also just looking at it from the perspective as they move into industry, engineers and has this engineering code of ethics, and business both have legitimate reasons for different decisions they want to make within the organization environment, and they're all justifiable. But how are those decisions led through an ethical framework? And so we have a framework that they can go through to kind of look at each of the different stakeholders, the objectives that the stakeholder is trying to address, and what are the focus of for each of those. And so we like to think about ways that we can utilize these different frameworks to help them kind of think a little bit more critically about those ethical types of decisions. Cool, thank you.
And just to wrap up, the feedback we've gotten from students is very positive. We find that students are really eager to put their engineering education within a social justice context. We've gotten a lot of comments about appreciation for, kind of discussing these types of cases in class. And here's just one quote I'll leave you with. I really appreciated the presentation on bias in the engineering field. Too often this kind of stuff is swept under the rug. So it's nice to have a candid conversation about it in class. So this encourages us to kind of develop this further, to keep working. And yeah, we've been excited about kind of the things that we've seen students present based on this. All right. Thank you very much.